Hello everyone. So next third unit we will complete eudiometry. So eudiometry is a process by which we can estimate molecular formula or mix that composition of elements in any given compound. So for this we need one long discharge tube that is called eudiometer. Like in atomic structure, we used long glass tube for discovery of electron and proton, cathode ray and anode rays. Same like that, long discharge tube we will use for the estimation or for to analyze the mixture composition or that molecular formula of any compound. So here you can see that compound is heated or burnt in a tube is called eudiometer. It's called eudiometer. And product gases are analyzed at constant pressure and temperature, means at STP or constant pressure and temperature as per question it will be given. So in that particular, that when that reaction is happening, let's suppose that hydrocarbon we are burning, so in that CO2 and H2O will be produced. So that CO2 and H2O, that gas is will pass particularly that gas from particular solvent, and in particular solvent particular gas only gets absorbed. So like CO2 will, this table you need to remember, because in question they will be given that this mixture of gas is passing through alcoholic KOH or turpentine oil. So you should know that in that gas, in that solvent, which particular gas will dissolve. So like CO2 is dissolving in alcoholic KOH, CO is dissolving in ammonical CuCl2, ozone is dissolving in turpentine oil, O2 is dissolving in alkaline pyragalol solution, and NH3 is dissolving in water, and H2O is dissolving in or absorbing in CaCl2. So CO2 getting absorbed in alcoholic KOH, CO is absorbing in ammonical Cu2Cl2, O3 is dissolving in turpentine oil, O2 is absorbing in alkaline pyrogalol solution, NH3 is absorbing in H2O, H2O is in anhydrous CaCl2. And N2 and O2 gases generally do not react. They will only react at very high temperature, means elevated temperature. And volume of solid and liquid we will consider as a zero. Why? Because it is long glass discharge tube. So with respect to that, this tube, whatever that volume of solid is there and volume of liquid is there, will be almost negligible. So here you can see that we are analyzing that molecular formula of hydrocarbon by using eudiometry. So let's suppose that hydrocarbon is CXHY. We don't know whether it is alkene, alkyne, what it is there, but we can calculate its molecular formula by using eudiometry. So keeping pressure and temperature constant, so you know PV is equal to nRT for gas, so number of moles of gas directly proportional to volume. So at T is equal to 0 initial time, this is the balanced chemical equation for hydrocarbon. And let's suppose initial volume is V1 ml and this is V2 ml. So this we will keep in excess oxygen, so that all hydrocarbon whatever is there, it must combust 100%. So after combustion it will form X CO2 and Y by 2 H2O gas. Clear? So from here what we will do, volume analysis. Since this is limiting reagent, so this will be completely consumed or completely combust. So this is 0. So from here if we will do volume analysis, so volume of O2 divided by its stoichiometric coefficient is equal to volume of hydrocarbon divided by 1. So from here we will get volume of that O2, how much is getting consumed, that is X plus Y by 4 into V1. Are you understanding? That we will do like here volume analysis. So volume of O2 divided by its stoichiometric coefficient X plus Y by 4 is equal to volume of hydrocarbon CXHY divided by 1. So this volume is V1. This volume is V1. Means from here volume of O2 is getting consumed how much? V1 into x plus y by 4. Understood? So overall volume of O2 is consumed since it is excess. So how much is remaining? V2 minus x plus y by 4 V1. And how much is formed? So through limiting reagent only it will be, we will do mole or volume analysis. So it is 1 mole, so it is forming x mole. So it will form x V1 and this will be y by 2 V1. Now what we are doing, that in that eudiometer, that we will decrease the temperature. So by decreasing temperature subsequently less than 100 degrees Celsius, water gas will become liquefy and it will become H2O. So due to that, what will happen? They will be somewhere in tube some drops of water. So volume of water we will neglect. So from here first condensate we will calculate that first how much that volume is decreased. So first volume contraction due to cooling is how much? Total volume initially it was V1 plus V2. Now total volume is how much? It's already this one completed. So only volume is there for O2 and volume of CO2. This volume we are neglecting. So total volume difference how much? V1 plus V2 initial minus now how much? X V1 of CO2 and remaining volume of excess reagent, that is O2. So from here we are getting this volume V1. This V1 is volume of hydrocarbon and 1 plus y by 4. So V Roman 1 is the volume first contracted due to cooling less than temperature 100 degrees Celsius, that is V1 into 1 plus y by 4. Then after passing through alcoholic KOH, so by passing alcoholic KOH, which one will absorb? CO2 will absorb. So how much it will absorb? So it will absorb x V1 because volume of CO2 is x V1. So it will absorb. So overall second contraction will be x V1. Clear? So in question what will be given? V1 means Roman 1, Roman 2 and volume of hydrocarbon and volume of oxygen which is there in excess reagent will be given. So from here x and y we can calculate. Okay, so here it is question that you can see 20 ml of hydrocarbon is given, means V1 is given, is exploded means that combust with excess of O2 and after explosion and cooling volume contracted was 60 ml, means V Roman 1 is given. Then resultant gas were passed through alcoholic KOH solution and further contracted is V that 80 ml, means this is V Roman 2 is given. Calculate formula. So V Roman 1 what it is? V1 into x plus y by 4. So here it is 60, 20 already given, y is coming 8 and V Roman 2 is given 80, x value will be here 4. So formula of hydrocarbon is CXHY is C4H8. Clear? Same like that you can see this question. 80 ml of O2 is passed through ozonizer. Ozonizer means again like that eudiometer, but since here ozonizer if we are telling means it is mixture of O2 and ozone. O2 and O3 ozone. When 25% of O2 is converted into ozone, calculate the volume of mixture after passing through turpentine oil. So here you can see that this that ozonolysis in that this that oxygen is getting converted into O3. So if we will balance this one, so 3 mole O2 is changing into 2 mole of O3. In question what is given? 80 ml of O2. So 80 ml of O2 is there and this one is 0. So from this how much it is converting? 25%. So 80 25% is 20 ml. So remaining 60 ml O2 is there. And this 20 ml will not form here 20 ml. We will do volume analysis. So volume analysis. So it will be 2 by 3 into 20. So overall 40 by 3 ml. Clear? Now is telling that calculate volume of mixture passing through turpentine oil. So turpentine oil which gas will absorb? O3. So how much is absorbed? 40 by 3. How much is now remaining? 60 ml. Clear? So asking that calculate volume of mixture. So after that passing through turpentine, this will be absorbed. So how much in mixture remaining there? Only O2. So how much volume? 60 ml. Clear? Next, like that only you can see that 100 ml of CO is mixed with 25 ml of air, and having 20% of O2 by volume, what would be final volume if none of CO and O2 is left after the reaction? Okay, so in question only it is telling, so we'll consider this one. None of volume of CO and O2. So here you can see CO and in air 25 ml of air, in that 20% is O2. So 25 ml, its 20% is 5 ml. So 5 ml O2 is there. So 10 ml of in that 100 ml of CO, I'm just taking its mole analysis according to that. This is 5, so here also this will be 10, because this 5 divided by a stoichiometric coefficient, this is also 10, and this one. So overall both will be completed together and forming 10 ml of CO2. Remaining 90 ml of CO, as per question it is telling, what would be final volume if none of CO and O2 is remaining. So O2 to 100% completed, CO we need to neglect. So after that how much? 10 ml of CO2, and remaining out of this 5 ml, remaining 20 ml of other gases are there. So that remaining 20 ml and plus this 10 ml, total how much? 30 ml is there. Is that clear? Okay, so moving further. Now you can see here 100 ml of O3 plus O2 means ozonide mixture is passed through turpentine oil, and thus reduction was 20 ml. How much volume is reduced? 20 ml. So if it is passing through turpentine oil, which gas will absorb? It will absorb O3. So 20 ml gas is that O3 is absorbed. So 100 ml of such solution is heated, what will be increase in volume? So 100 ml of such solution is there, means O3 and O2 is there, and in that what happening? 20 ml is means 20 ml what is there? O3. 80 ml what is there? O2. Clear? So here you can see O3 or such type of solution when you are heating, what will happen? So O2 will not dissociate, O3 will dissociate into O2 plus O. So on heating, O3 will break down into O2, 3O2. So 2 mole forming 3 mole. So 20 ml which absorb as per 100 ml. So 20 ml in that how much? On heating, it will become 30 ml. So remaining 80 ml of O2 plus this 30 ml, because such type of solution only we are heating. So overall O2 how much? 110. So total change in volume 10 ml, 100 minus that 110 minus 100. Clear? So like that, here we understood eudiometry. By this we can estimate composition of mixture, or we can calculate molecular formula of any compound. So next, after this further we will discuss redox reaction, and after that last unit will be our titration volumetric analysis. Thank you very much.